little about AWS IoT Core. So basically AWS IoT or the AWS Amazon Web Services is a premium and the standard web services platform available out there, and very so many companies and industries use the services from AWS, means Amazon Web Services. So one of the service is called AWS IoT Core, using which we can communicate with the cloud platform provided by the Amazon. We can connect the different devices to the cloud platform, and we can exchange the data and automate the things, or the exchange the data and monitor it and control it. So it is commercial platform, so it is not available free. So whenever you are creating a new account with the AWS IoT, you have to provide your debit card or the credit card. But for the first year, uh, as soon as you get registered for the first year, it is free tire, and after 1 year they will charge you according to your users. So how much service you are using, how much uh, data you are using or consuming, all the parameters are there. So depending upon that, they will charge you. So it is not like that fixed charges are there. It depends upon the users, how much do you use the service. So I'll just simply type AWS, and then just simply click on cloud services, and after that click on my account and AWS Management Console. As I already have created account on this console, I cannot create it again because it will require again debit card or credit card. So I'll just show you how to sign in. The creating your account is very simple. You just need a credit card or a debit card. After creation of account, just open this platform and click AWS Management Console. Click here and then just sign in. Just make sure that you have selected root user and then type your email ID with which you have created your account. In my case, it is 1705014 rit.edu. I'll type these characters 4QF2. Okay. And then type your password. Sign in. After signing in, this AWS Management Console will look like this, and all the services which are available you can see here. But among these all services, we want to use AWS IoT Core. Just to do that, just type into search bar as IoT, and you will find this IoT Core here. Simply click on it. IoT Core section. That's it. After this, all the configuration required to do in AWS Management Console, I will discuss later. Just make sure that you are here. After this, there are two types of configuration required in case of AWS IoT. We have to configure some structure into the AWS IoT, we have to create things, we have to create certificates, we have to create policies, and we have to attach those policies to the certificate and the certificate to the things again. So in that case, there are two types of configuration on the cloud side, on the Arduino side. So this configuration, I will do it later. The first configuration which we are going to do is in Arduino IDE. So I will just open it. Now I'll open the new file. Previously, when we were working with the Firebase, we installed few libraries dependencies from managed libraries. We installed JSON library, and the particular version for that was 5.13.2. But in case of AWS IoT, we have to make sure that it is up to date. So we cannot install the old version of Arduino JSON for the AWS IoT. So understand the difference between whenever you are working with the different cloud platforms. The dependencies are different, dependencies versions are different. So in case of Firebase, it was the older version of JSON, but in case of AWS, you just have to install the latest version available out there. So I'll just simply type JSON and search for Arduino JSON by Benoit. Now the version you can see here, it is 5.13.2, but the latest version you can see it is 6.18.5. So what I will do, I will just simply click on update. Now you can see the updated version which we have installed is 6.18.5. Okay, make sure that if you do not install the latest version for the AWS IoT, I'm particularly talking about the AWS IoT core platform, it will show you error. Now in case of board also, you have to make sure that you are installing the latest version of ESP8266 board. So previously for the Firebase, we installed the 2.5.2, but in case of AWS IoT Core, we have to install the latest version, and the latest version is 3.0.2. So I'll just make sure that we are updating the dependencies and the board to the latest version. So 3.0.2, we have installed it correctly. After this, we do not have to install any other libraries externally or internally. The only library which we needed to install was JSON library, which is installed internally using the managed libraries. And after that, we do not have to install any other libraries, because whenever we are installing this ESP8266 latest board, along with that, it comes with the pre-installed some libraries, so that we do not have to install them externally. After this, we have configured the software for AWS IoT Core. Now it is time to use a library, this ESP-MQTT AWS IoT Core master. So what we have to do, I will provide this zip library, right click on it and extract. So we have extracted into this folder. I'll open it. So you will see these files are available, and among these files, open the Arduino and just simply select this PubSub client. Just ignore these other two files. See, PubSub client. Open it. Now you can see here PubSub client is there. If you are using ESP32, In that case, you do not have to change any configuration. You just have to select the ESP32 board from here, and this code is written such as that it is compatible for the both boards, ESP8266 as well as ESP32. So you do not have to change anything. This code is written for both of the boards. And some of the libraries which are required, Wi-Fi client, secure.h, pubsub client.h, Arduino JSON.h. These libraries we do not have to install externally. These come with the, whenever we install the board, it gets installed automatically. So only library which we have installed is JSON, and that we have included. So you can see here, use version 6.xx. It means the version which is latter of 6 point, just use that. So previous version was 5.13.2, so it will give error. So these are some dependencies. I'm not going to talk much detail about what each library does. The secure, as its name suggests, it is used for the TSL encryption. The certificates we are going to add into secret.h file, all that. So it is related to the security part. Just assume that for now. After that, we have included the secret.h file. We can see we have to configure this file, and then we have included that into the code. So in case of Firebase, we got some credentials from the cloud platform, like host was there, host link was there, and the database secret was there. So in case of AWS IoT, similarly, we have to download some credentials and we have to include those credentials inside our code, so that using this code, we can program the Tesla board, so that Tesla board can communicate with the AWS IoT. And after that, it is MQTT port, MQTT 8883. This is a secure TSL port. It is a secure port. There are different types of ports available. What is port, what is sockets? You can learn about that on the internet. And this is the secure one. 8080 is there, 443 is there, different types of ports are there. So it is among those ports, it is the secure port. So whatever the communication or the data transmission will happen between the Tesla IoT board or the Wi-Fi module with the AWS IoT, it is going to be encrypted or the secure, much more secure than the Firebase, because as already have said that um, Firebase is used whenever you want to do some prototyping or some simple projects. In those cases, you do not need much security or the encryption. But in case of some standard project or the commercial product, if you want to build, you need so much higher security, the encryption. In that case, we must use the standard uh, cloud platforms such as AWS IoT. So many industries use AWS IoT. So this is the PubSub subscription topic, published topic. So I will discuss about the MQTT protocol. In that, we are going to cover what is subscription topic and the published topic. All these lines are just to read the certificates and make sure that they're right. This is for the timestamp. So whenever we are sending some data, it will add a timestamp. So to create real time, we have written this code. So message received is there. So whenever we'll receive any message, so using this function, we are going to receive that function. So I will send some data from the cloud to the Tesla board. In that case, this function will be useful. PubSub error is there. So there are so many functions are included in this code. I'm not going to discuss all this. So whenever there will be some error, this function will get called, and depending upon the error ID, it will show the what is error. Connect to MQTT. It is for connection. Connect to Wi-Fi. So previously we have seen in Firebase, in case of Firebase, how to connect with the Wi-Fi. So Wi-Fi related code is here. Check Wi-Fi, then MQTT. If there is some reconnection, in that case, we are checking it. So different functions are there. So important function, this receive message, two important functions, message received and send data. These functions, these two functions are very important, with which we are going to play with, because whenever we want to send some data, we are going to use this function, and whenever we want to receive some data, we are going to use that message received function, this function. So we will change some things here and the void setup. So whatever the code inside the void setup will run for only for one time. So in this case now, baud rate is 115200. Now what is thing name? I'll discuss when we are configuring the cloud side part. And then again, we are sending the data from here. So this is all about this main code. And after that, we have a header file, secret.h. Inside this secret.h file, we are going to include all the credentials from the AWS IoT Cloud so that we can connect with it. So what I will do now, I'll just discuss this header file first. So we have to provide this thing name here. Thing name we are going to get from the AWS IoT. After that, we have to provide the time zone, which is positive 5. I will just keep it as 5. Previously, it was -1. MQTT host, again, we are going to get this host from host or the endpoint. It is also called as endpoint. We are going to get it from the AWS IoT. And then there is CS certificate, server authentication certificate is there. Client certificate is there. The content of client certificate, we have to include it here. And the private key is there. So all these credentials, we have to get it from AWS IoT. So all the configuration related part, we have to do it in secret.h file. So SSID is there, all this, we have to change this. Okay, and all the required credentials we are going to get from AWS IoT. Now, I have discussed how to configure the software first. Now, I will discuss how we can set up AWS IoT core so that we can communicate it with using Tesla IoT core. So whenever you are logged in into the AWS IoT core, you will see the user interface like this. Sometimes like this, you just have to click here and then go to, so many options are available. Don't be overwhelmed, just select the manage. Simple steps are there, just remember to follow every step. If you miss any step, you will not be able to communicate with the AWS IoT. So just simply click on manage, then go to things. Now previously I have created some things for testing purpose. So what I will do, just simply click on create things. Now create a single thing. What is the thing first I will discuss. In IoT, IoT stands for Internet of Things. Things is nothing but devices, the appliances connecting, or the computer cloud platforms, everything connected with each other, the devices. So I will just use the thing as devices. In our case, the device is Tesla IoT board. And for that, we are going to create a thing. That thing is nothing but Tesla IoT board. Let's just click next. So you have to provide the thing name. So I'll provide as Tesla IoT. Okay, I have provided this name. I will just add again FDP for clarification. You can provide any name you want. I'll just provide Tesla IoT FDP thing name. After this, just keep everything. These all things are optional. Okay, just skip it and just click on next. Now it is very important part. Device certificates. Auto generate a new certificate recommended. Always select this part if you want to easily connect your device with the AWS ID code. In case of use my certificate, upload CSR, skip creating certificate at this time. You have to be expert in the encryption, network security, AWS cloud platforms, then you can go with these other options. But if you are new beginner, just select the first option, auto generate new certificate. Then click next. Now here, attach policies to certificate. It is optional, but we have to attach the policies. For now, what I will do, I'll just skip this part and just click create thing. After clicking on create thing, you just have to select this certificate and download it. So this is device certificate. After that, we do not need public key, but it is mandatory to download it just so that I just download it. Then private key is there, I have downloaded, and the root CA certificate, and I will download it. The first CA1. Okay, I'll close it. Hello.
Number 6.
Please turn off your microphones, please. Now click on done. Okay, you successfully created thing Tesla IoT FDP. You successfully created certificates. Okay, just close this. Now you can see we have created this thing Tesla IoT FDP. The next part is, after creation of this thing, we have to attach policy. Policy, what is policy? We will understand policy. So to attach the policy, go to secure first, and inside the secure you will find this policy part. So what we will do, we'll create new policy. I'll explain what is the purpose of this policy here. So we have to provide the name first, so I'll just make it Tesla policy. Give any name you want, doesn't matter. And see, policy statements define the type of action that can be performed by a resource. In case of resource is Tesla IoT board. So Tesla IoT board can be able to do what things it can do. This board can do. We have to mention here. For example, if I type IoT, or just simply I, it will show the all actions available here. So if I select this publish here, so our Tesla board will only be able to publish the data to the AWS IoT core. If I select subscribe, so that only data Tesla board will only be able to subscribe and receive data, but not to send data back. It will only receive the data. So many actions are available. So what we'll do to give all the actions so that we can perform, so we can have flexibility in our project, we just have to add asterisk sign, star sign here. This means we have given access for the all actions to the Tesla IoT board. Now Tesla IoT board can publish, subscribe, connect, do all the actions available. And here also we have to provide resource ARN as star. This means resource ARN can be anything. After that, click here, allow, and then create. Now Tesla policy we have created. These are previously created policies. Some policies are there. Now what we have to do, after creation of this policy, we have to attach this policy to the certificate we have created, the certificate which we have downloaded. Certificate, you can see the public key is there, certificate is there. So this certificate, we have to attach these policies to this certificate. So after creation of this policy, go to certificates. Now how to check to which certificate we have to connect this policy. So just simply click on it and you will go to things and you will see this certificate is related to this particular thing we have created, Tesla IoT FTP. Just go back, go to certificates again, click on these three dots and select this attach policy, and it will show the all the policies available, and among which we have to select the Tesla policy, the policy which we have created to give all the access to the Tesla board, and simply click attach. We have successfully attached the policy. Now if I open the Tesla IoT FTP, the thing which we have created, you can see the certificate here. So make sure that whenever you are creating this thing, you download the certificate, because later you will not be able to download the public key. Public key we do not need, but the private key or the certificate we will not be able to download it. So make sure that initially while you are creating, you download the required certificate and keys. So later you will not be able to do that. Now all the configuration and the creation of the things we have done here. That's it from the cloud side part. Everything is done. I'll just close it. Now you have to add the credentials here. The SSID's project is my phone's hotspot ID and the password is computer 12345. After that we have to provide the thing name. What is thing name? The name we have created, we have given to the thing we have created on AWS IoT. So just have to copy this. See, you can simply copy from here also, or you can type it. Control V. After that, we have to provide this MQTT host. Now, what is MQTT host? So it is endpoint. It is called as endpoint. So from where we can get it, just scroll down and click on settings. And you can see endpoint is here. Just simply copy this and then paste it here. After this, we have to provide the contents of C certificate inside this array. So what I will do, I will just go to downloads, where we have downloaded those certificates and public and private key. Go to downloads. See. So I will open it with the any editor you have. You can open it with the notepad as well. So I have notepad++. So whenever you will open, you will see the content like this. Just simply copy it and erase everything inside this array and paste it. Okay, we have pasted the contents of CA certificate inside this. Now it is time for client certificate. Just minimize it. This is our client certificate. You can see certificate.pl. This is client certificate. Right click on it. Open it with Notepad++. Again, copy the contents of this certificate. Control C. And paste it here. come for the private key. So you can see here it is private key and it is a public key. So in case our case, we do not need any public key. So we just need private key. Right click on it and copy the contents of private key. Control C. Done. All the configuration and the credentials we have added into this secret.h file. Now we are ready to program the Tesla board using this program we have, PubSub client, so that we can connect it with the thing we have created on the AWS. But before uploading the code or before compiling the code, we will discuss a little about the MQTT protocol. What is MQTT protocol? So I will just not talk about the MQTT protocol. I will just open the website. I will show you what is, so that everyone can better understand what is MQTT protocol is. So before that, I will just compile it, make sure that everything is correct we have done so far. It will take some time to compile. Done compile. That means everything we have done so far is right. Now it is part for the MQTT protocol. We will discuss about what is MQTT protocol and how we can use it. MQTT.org website. So basically what I will do, I will just simply read this because it is very short given. So MQTT, the standard for IoT messaging, and it is used in industries, companies, wherever there is IoT product are involved, IoT systems are involved. The MQTT protocol is a standard protocol. There are other protocols available out there, but in most of the cases, most of the industries, MQTT protocol is preferred. And why it is preferred? It is given. So MQTT is Oasis standard messaging protocol for the Internet of Things. It is specially designed for the IoT. It is designed as an extremely lightweight publish subscribe messaging transport that is ideal for connecting remote devices. In case of remote devices, now Tesla IoT board. So in case of devices, there can be multiple Tesla IoT boards connected at different locations, and they are communicating with each other, exchanging data. That we can do with MQTT protocol. So remote devices with a small code footprint and minimal network bandwidth. MQTT today is used in a wide variety of industries such as automotive, manufacturing. So these are some why MQTT. These are the advantages of MQTT is provided here. So in our case also, we are using this TLS encryption, transport layer security protocol. We are using the keys or the credentials we have added, the private key and the certificate. These all are related with the encryption, TLS, transport layer security. You can just simply go through this mqtt.org if you want to learn more about the MQTT protocol. I'll just read, highlight this. You can connect as many as things, means the devices you want using MQTT protocol. So MQTT protocol makes sure that your message is delivered. You can see that it is given here. Now we will understand the architecture of this MQTT protocol. So I will slowly explain this protocol because it is very important. First, just assume that MQTT broker is nothing but mediator. Mediator means uh, the system or the platform which is used to connect different devices. Now, in our case, we are using AWS IoT. So AWS IoT is nothing but MQTT broker. It has its own MQTT broker. So it is a mediator between all devices. It means that to the MQTT broker, means AWS IoT MQTT broker, we can connect all the clients devices. So this is the mediator, and the client devices can be Tesla IoT board, it can be uh, smartphone, it can be other servers, it can be a computer. The client can be anything, a software, Android application, Tesla IoT board, so devices. So all these devices, all these clients, all are connected with the MQTT broker, and the MQTT broker, in our case, is AWS IoT Core MQTT broker. So it is mediator, and all the clients are connected with this MQTT broker. Now understand how message delivery works here. So just assume an example. If we want to send temperature data, so we are collecting some temperature data of a remote location, for example, for a particular room, classroom. We want to measure the temperature, and we want to send the temperature data to a remote computer or some Android application remotely. For example, the HOD or the principal wants to read this data remotely sitting in his cabin of this particular classroom. In that case, what we'll do, we'll connect the Tesla IoT board using MQTT protocol with the AWS IoT. Now, AWS IoT is the broker. We have connected Tesla board to it, and the principal smartphone will be another client, another MQTT client. But in that case, he just wants to read the data. So he will be subscriber. And in case of Tesla IoT board, in case of Tesla IoT board, it will be publisher. So it will publish the data to the broker, and the broker will see who is subscribed to this particular topic. The topic is here given temperature. So we can create different topics. So you can see in the code. So different topics are created. So whatever data, temperature data we will create, we want to put, we want to send to this particular topic. So this is publish topic. So data, whenever we send any data, we are sending data to this topic. So whoever connected to MQTT broker and subscribed to this particular topic, I'm just giving a general example, to particular topic, it can be temperature, it can be this topic, can be anything. So whenever we are publishing particular temperature data to this topic, and the client which are connected to the MQTT broker and subscribe to this particular topic will receive a message, will receive a notification, will receive the data, whatever data we are publishing. So this is what all MQTT is. So in case of, I'm just publishing, so publishing to this particular topic temperature, and all other clients are subscribed to this topic. So whenever I publish any data, they all will receive the data, temperature data. So suppose just few of the clients have subscribed to topic, temperature topic, and few have not subscribed. We just assume that this MQTT client is not subscribed to this temperature, and this client is subscribed to temperature. So only this client will be able to receive the data from this client. So understand the structure. This all clients are connected to each other via a mediator. It is called as MQTT broker, and they're exchanging data using MQTT protocol. So in our case, Tesla board can we can send it to for publishing as well as subscribing. Means we can send it the data using Tesla IoT board. We can receive the data as well as.
So there is a limit on the subscriber or the publisher.
Sir, I'm clearly not. I'm not able to clearly hear you. Can you repeat?
There is some limit on the number of the subscriber or the
No. There can be unlimited. See, you can scale up to millions of things. MQTT can scale to connect with the millions of IoT devices. You can connect as many as devices you want to the MQTT broker. So try to understand this MQTT architecture. After this, what we will do? We are similarly same protocol we are using in this code. So using pub/sub, pub means publish, subscribe, client.h. Using this library, we are implementing the MQTT protocol. So what I will do now? I will connect the Tesla IoT board. With the AWS. Select the correct component. It is 5 in our case. Yes, it is 5. Board we have selected. It is up to date. You can see 3.0.2. Now just hit upload. Make sure that all the credentials required are correct. Then I will turn on my mobile phone's hotspot. I've turned on the hotspot for these credentials. Project and computer 1 2 3 4 5. If everything is correct so far we have done, then it will get connected with the AWS. I have to change the baud rate. Baud rate is 11. So what I will do, I'll just clear the output and reset the node MCU. It is connected to the SSID. It is trying to connect with the AWS IoT now. If everything is correct, it will show MQTT connected. Yes. It is sending some random values from AWS to the AWS and also receiving the same data. What we will do, we will check whether we are receiving the data at client. To test, we are receiving the data from Tesla IoT board. What we have to do, we have to go to test and click on MQTT test client. It is client provided by the AWS. It is not the broker. It is not part of AWS. Means it is the part of AWS, but it is not part of our project we have created. It is an isolated test platform. So what I will do, to check whether we are receiving the data or not, we have to subscribe to this particular topic. Because we are publishing data to this particular topic, we must subscribe this client with this topic. We have to provide the correct theme name here. The theme name is Tesla IoT FDP. We'll copy it, Control C, and paste it here, Control V. Now, as soon as I will click on subscribe. If we start to receive the messages on this console, it means that we are successfully sending the data. We are successfully publishing the data, random data from Tesla IoT board to the cloud platform. I click. Okay, there is double quote is there. That is the reason we were not receiving the data. So this small things can make errors. So I will subscribe again. Yes, we received the data. Yes, we are receiving the data. You can see state reported value 68. We'll compare from here. I'll just clear the output. Now it is 86. You can see 86 is here. Now the 6 is there. 6 is here. 21. Again 21. 92. 84. So whatever data, random data we are sending from the Tesla IoT board, we are receiving at this client. Now what we want to do, we want to send data back. So what I will do, I'll make few changes. So instead of this, I'll add a new topic, sorry, as data / AWS / IoT. Okay, enough. I will create this particular topic, and now again I will do, I will program. I'll upload this program. So now our Tesla IoT board is subscribed to this particular topic. So whenever we send any data using this publish to this particular topic, this data AWS IoT, whenever we publish data to this particular topic from this client, we'll be able to receive that data into Tesla board. And depending upon that, we can take some action. For example, action can be to turn on the LED, to turn on the relay, to turn on the buzzer, to turn on the motor, to control the speed of motor. You can do anything you want. Once the data is in the Tesla board, you can do anything with that using comparison methods. Now it is trying to connect. I've reset it again. There is little network issue of my mobile phone. Sorry. So we'll try to connect again with the MQTT. Connected. Now see, in previously, whenever we were sending the data, we were subscribed to the same topic, particular topic, and as soon as we send, we were receiving the same data. But now we are not receiving the data, we are only sending the data. What I will do, I will just copy this topic, Control C, and I'll publish data, Control V here. So I will just uh, keep this text as it is, hello from AWS IoT console. So as soon as I publish, we will be able to see the received data here. So there is no received data because we have not published it yet. So I will click publish. I have clicked publish. See, we have received the data. Message, hello from AWS IoT console. If I send anything else, like now I will publish this data. So I'll just first check. We'll just check. So we are only sending the data because we have not published it yet. Now I'll publish it. This data. See, IoT FTP using Tesla IoT Board. So whatever data we are sending from AWS, we are receiving it at Tesla IoT board end. So depending upon this data, we can take any action. Now instead of string, we can send numbers as well. I'll just add some random numbers and then publish it. See, we have received this number 14568 and vice versa. We were subscribed to this topic also. We are receiving the data from the Tesla IoT board and we are sending the data from Tesla IoT board to the Tesla IoT board. Sorry. Now what I will do, I will close everything. Now we will do some action part. So already I have written some code. I'll close it. I'll copy the credentials which we had added in the previous file. I will just simply copy them because else we have to do it again. And this code which I have written previously yesterday means for today's session. So using this program, what we can do, we can control the LED or any peripheral available on the Tesla IoT board using AWS IoT. So whenever I will send any command from the AWS IoT, it will get executed here, like LED on, LED off, likewise. So I'll just select Control A and erase it, and Control V. Yes, we have copied this, all the credentials. Now what I will do, I will make sure that port is connected. Yes, I will upload this code. I will quickly explain it. So I have changed the subscription topic. Here you can see, and we are updating data to this particular topic, the publishing data. The only thing which I have changed is whatever data we are receiving at the Tesla board from the AWS IoT, I am filtering the data using this filter function. You can see state reported command, and from that I'm extracting the data. So you can see here, so all the extraction is done. I'm just checking if the LED is off or LED is on. Depending upon that, I'm taking action. So that's the only change. And at the same part, So in previous program, we used to send random data, random number data. But in this case, what we'll do, whatever we type in the serial monitor, that will get printed into the AWS. So we'll check if we get connected or not. Yeah, okay. MQTT connected. Now what I will do, I'll just copy this topic. First, we will send data from the Tesla IoT board, data which we want. In previously, we were sending just random data, but in this case, the data whatever we want, we'll send it. Theme name, add the. Do not forget to add the theme name. Get subscribed to it. So whatever data we will send, it will appear here. So now I want to send some random text. First we will send some random text. Like I want to send hello. If I hit enter, sending, it means we have sent the data and we received the data. User data from ESP8266. We received the hello. Now, if I want to send Tesla IoT, hit enter, send. See, we received the Tesla IoT. So whatever data we want to send, we are sending it here. Now what I will do, we'll try to control the LEDs or the peripherals available. I'll just copy the structure because I'm using the same JSON structure. Wait, I'll check the code. State reported command. We are filtering the data from this structure. State reported command. So we must type this here. State reported would be LED on and LED off. So I will just type LED on. I'll just make sure that this is the command. So command is LED off. We are comparing it with this LED off and LED on. Okay. And the pin number is 5. You can see we are controlling the pin number 5. LED on. Now we must mention here to which topic we are sending the data. Copy, because we are subscribed, Tesla board is subscribed to this particular topic. So and I will connect pin number 5 to the LED. Hope it is visible, and now I will publish. See, LED is glowing. I'll make sure that it is clearly visible Okay, it is visible. Now what I will do, I'll make it off. I'll publish it. Yes, it is off. I'll make it again on. Yes, it is on. Now what I will do, if simply I want to control any appliances like TV or fan, I just have to put this pin to relay module. Now currently it is on. So what I will do, first I will make it off so everyone can hear the relay tick. Now I will connect it with the relay module and then I will publish on. See, you heard the relay tick sound. I'll make it off. I'll make it again on. In case I will just connect it with the buzzer. So controlling Tesla board from AWS IoT. Now we turned off. Now, as I also know that it is very hectic and not feasible to control any appliances from the AWS IoT console. You have to log in, sign up, and then do all these things, create the structure. It is not feasible, I know, but you can connect other websites, Android application with the AWS IoT, and simply you just have to press a button instead of writing this all the JSON structure and the publishing. You don't have to do it all. You just have to create an application. You just have to click it, turn on the LED, turn on the fan, whatever you want to do, create just application, connect with the AWS IoT, and just you're ready to go. You can control Tesla board from your Android application or any other website. So what I will do now, we have seen how to put random data, whatever data we have typed, but we have not seen how to put sensor data. So what I will do, I'll use a onboard sensor. For example, I will use LDR sensor as input, and we will observe that data. In real time, I will change the data, and you will be able to see on the screen. So I will connect with the analog pin and the light output, LDR output pin. So we just have to make few changes in the code for that. So first thing, whenever we have to go to send function, okay, whatever data we are receiving, we are printing it here. So I will comment this and I'll write it here, analog read A0 pin. You do not have to mention it as input or output on the setup in the setup code block, because it is the only pin and it is always in input mode. So that is the reason we do not have to mention it as input. So whatever data we are getting at the A0 pin, we are sending it to the AWS cloud. I'll just make this code as well. I'll change it. So I'll remove everything else. Hope it works, because it can cause many errors in real time changing this code. Delay. I will add 2 seconds of delay. We will update the data every 2 seconds. And I will hit upload. Easy as that. You just have to add a single line. Okay. I must remove this. You just have to add a single line, and using that single line, you can read the data, analog data, and you can put it into any cloud platform you want. We'll check that. Yes. And see the data we are sending is 80. What is the real-time data is there? We are sending it. So I'll check. See data from ESP. It is as it is a 10-bit ADC. The values will range from 0 to 123. The 1023. So what I will do? I'll change. See, the value is 98 now. I have covered the LDR sensor. If I remove the finger, it will show the higher values. The maximum value it is showing now because it is in front of the screen. I'll cover it again. Now again it will show the higher values. If I cover it little bit, it will show those numbers. So if I change it, I'll again cover it. I'll try to make it as black as possible. See 12, we are receiving the 12, 8. So you can see how it is easy to send and receive data using Tesla IoT board. We are using onboard sensor, which is LDR. So you can do it. You can interface any external sensor. You can use the temperature sensor. You can use Hall effect sensor. You can interface any external peripheral, all the module, and control it and read the data. You can do it very easily with the Tesla IoT board. Now you can remotely read or to monitor this data using an Android application or a website. So this is all about the second session, connecting and communication between AWS IoT, which is a commercial and the industry standard IoT platform used. So we have seen this in the second session. Now what I will do, I will briefly discuss about this Tesla IoT board, how it is available in the market, how you can buy if you are interested, and about the training program. So I will close it. The Patil sir. Patil sir. Patil sir. Just 1 second. Sir. Just 1 second, then we will discuss about this board and the training program we provide.